airline systems, and more specifically air traffic management systems, are one of the most complex systems in the world to model. This of course means that they offer us a plethora of optimization problems to work on. One of the difficult problems in airline systems and air traffic management is what is called as departure pushback control. So what is departure pushback control? Imagine an aircraft that is parked at the gate, has boarded its passengers, and is ready to push back to take off. The pilot requests air traffic control to give permission for pushback. Now there are two considerations here that we would need to look at. The first, if there is too many aircraft that are already in front of the runway, queued up in front of the runway, then there is no value in this particular aircraft pushing back, because the moment this aircraft pushes back, it's starting to burn fuel. On the other hand, if the aircraft continues to hold at the gate, then they naturally end up paying what is called as a gate parking fee. Typically, airports would allow an aircraft to stay at the gate for about 15 minutes to 20 minutes beyond their scheduled departure time. But if you exceed that time limit, the aircraft or the airline in particular would then have to pay the airport what is called as a gate parking fee. And therefore, now there is a really neat optimization problem for the air traffic controller and the air traffic management system, where if you allow the aircraft to push back, you're burning fuel, whereas if you continue to hold the aircraft at the gate, you are now paying a gate parking fee. So how do you optimize this particular process? What is the optimal decision that needs to be taken? When do we allow an aircraft to push back and join the queue? To be able to do this, we've modeled this problem using Monte Carlo simulation, using data that's available to us from one of the world's largest airports. We've been able to model this as a simulation problem. And moreover, we've also built a continuous time Markov chain model that now allows us to determine when an aircraft should be pushed back or not. This paper also provides many policy alternatives to decision makers that helps them make better decisions with regards to controlling aircraft on the ground. It's a fascinating problem to work on, and there are many other additions that we can look at. Thank you.